Now we go to the next topic. It's a low frequency response. Okay, this is for the low frequency response. The RC coupled circuit is like this. Okay, we have capacitor here, and we have R here, resistor, and here is the V in, and this is the V out. Okay, so during the low frequency response, from this circuit, okay, we get the derivation of the equation is like this: V out over V in, and we had this one, J omega RC divided by 1 plus J omega RC, and finally we get this equation. So from this formation equation, the lower cut-off frequency now, F1, okay, is omega 1 equal to 1 over RC, or F1, which is the frequency, is equal to 1 over 2 pi RC. Okay, so normally we want to find what is the frequency during the low frequency response. So this is what we want to find. Okay, in the low frequency response, the magnitude of the gain in decibel, okay, in decibel. So this is the formula to get the magnitude, or we say that actual response. Okay, the actual response of the gain. What is actual response? Actual response is the curve that we see in the graph. Okay, so the formula is AV low equal to negative 20 log for this one. Okay, then if this equation, for this equation, if the frequency, the cut-off frequency over the frequency squared is greater than 1, which is this one. Okay, if this frequency is greater than 1, this equation become like this. Okay, so it's simplified to this one. This is the simplified formula from the first one. Okay, so it will get the asymptote here. What is the asymptote? Asymptote is like a sketch line where we draw for the frequencies that we get. Okay, it's difficult to say to explain here. I will show you later in the example how to get the asymptote. What is the difference actual response and the asymptote? Okay, next we go to the method. Okay, to do a frequency plot in decibel, we call it Bode plot. Okay, the first one, find the frequency. Okay, frequency F1. This is this frequency we get from the formula F equal 1 to pi RC. Okay, as the previous formula. And then second, we sketch an asymptote. Okay, this asymptote, the slope is at 20 dB per decade. And the third one, we find the negative 3 dB point corresponding to F1. Remember that this frequency, okay, then we had the negative 3 dB point. Okay, finally we sketch the curve, which is the actual response, okay, using this formula. Okay, you can see here. Okay, in BJT amplifier, the RC combination, okay, or like I said before, the RC couple circuit, the resistors and capacitors involved in this one is CC, CS and CE. Okay, these three capacitor will define a low cut-off frequency. At frequency equal to 0, here, frequency at 0, the capacitive reactant XC, okay, and the capacitor become an open circuit. This XC is equal to infinity when F equal to 0. See this equation. Okay, when when the frequency is at 0, we divide this equation 1 over 0, we get infinity. So when the reactant is infinity, it means that it become an open circuit. So this capacitor now is open circuit, so no current flow here. Therefore, here I equal to 0, so V out now equal to 0. So for this one, when V out equal to 0, okay, so we get gain equal to 0. Now our gain is here, 0. Means that during F equal to 0, so the gain is 0. Okay. Okay, next, when the frequency increase a little bit, okay, the capacitance reactant XC is decreased. Okay, this is because using this equation, we have some value here. Let's say I put F equal to 10, and when we calculate, its value is depending on this F and C. So if this frequency is increased, and this reactant will be decreased, its value will be decreased. So we cannot say here is open circuit, the capacitor is still here. Okay, so then we calculate here, and then because of this, we get the V out. Okay, V is V out and V in here, so it increase a little bit here. Okay, when you increase the F, so the reactant will decrease and the gain is increased. Okay, at very high frequency, okay, very high frequency, the capacitor reactant XC becomes 0 and the capacitor become a short circuit. Okay, when frequency is very high, okay, we divide 1 divide by 2 pi FC, and this value become very high, so the output it become very small until it reach to 0 ohm. So here we assume that when the reactant is 0, our circuit become a short circuit. Okay, when it becomes short circuit, you see it's like no resistance at here, so we get our V out now is equal to V in. So this is the maximum value when we get V out over V in now equal to 1. So now the gain is here. Okay, mean here is a maximum when VF is very high. Okay, so we get here. Okay, you can see the 3 different level. First at F equal to 0, then F somewhere here until reach this area, and then this is for the very high frequency is here. Okay, this is a 3 situation for a different frequency during the low frequency response.